Hi guys, so it's me again, Mr Hutton Science. Hopefully you're not getting too bored of these videos, and hopefully I'm sounding a little bit more cheerful. I've really worked hard on that, so hopefully you guys aren't sounding, you don't feel like I'm quite as boring as I was. So, I'm really excited about this video today. So, the video about ions. I spent a lot of time on this, and hopefully you'll appreciate some of the amazing graphics you've got coming up. But before we do that, of course, make sure your mobile phone is off, make sure you've been to the loo, you've got yourself a drink and a pen and paper, and you're ready to go. So as always, this video is here to accompany your AQA GCSE chemistry course. So I think to understand ions, guys, we really need to understand what atoms are first. Okay, so an atom is the smallest possible form of any element, okay? We've got the nucleus in the middle that contains our protons and neutrons, and around the nucleus we've got energy shells with our electrons on. Okay, the number of protons is equal to the number of electrons. That's why normal atoms have no overall charge, because they have an equal number of positives and negatives. So information about atoms can be extracted from the periodic table as well. So remember, we can look at what group they're in, that gives us information. We can look at the number of protons, that helps us with our electron structure. Okay, we can even look at the period that they're in the periodic table, and that will help us with the number of shells. So there's lots of information on that periodic table which you get for free in your exam. So know how to use it, because it is extremely helpful. Okay. So here we are. You've got an example there of, what have we got? 1, 2, 3, 4, 5, 6. So that's carbon up at the top right of your picture there. And you can see in the nucleus there's the protons and the neutrons. And you've got 6 protons and you've got 6 electrons on the outside on the energy shells. So you've got 6 positives and 6 negatives. And that's why a normal carbon atom is neutral. So in terms of knowing about our particles, let's have a look. We need to know, you need to know about charge and mass and where they are. Okay, so let's have a look. So a proton has a charge of +1. Hopefully you knew that already. A neutron is neutral, has no charge, and an electron has a charge effectively of -1. All right. The mass of our protons and neutrons is relatively speaking 1. Okay, and the electron is considered to be very, very small, tiny mass. Okay, that we kind of ignore it at this stage, and it's 1/2000. So you can see that the only two things that have mass are our proton and neutron, and they're found in the nucleus. So this is why we say that the mass of an atom is found in the center, in its nucleus. That is where the mass is concentrated. And the electrons, they're found flying around the outside on our energy shells. Right, so from the periodic table, how is this going to help us? So the graphic I've got here is slightly different to what you'll see on your standard GCSE periodic tables, only because the proton number and the relative atomic mass have been flipped. They've changed places. But remember, your proton number is the small number and your relative atomic mass is the bigger number. So whichever way round it is, okay, if you've got a periodic table that your mum and dad have used, which is a bit old, or your granddad and it's a bit old and it's the other way round, or you're over in America and it's the other way round, remember, the mass number is the bigger number. It's always the bigger number. And the smaller number is the proton number, or the atomic number. Right. So, in order to have no overall charge, I've said this a few times already, but the number of electrons in a neutral atom is the same as the number of protons. You've got the same number of minuses as you've got positives. And therefore, when they come together, there's no overall charge. Okay, so that's atoms. Right. Let's go on to ions then. What are ions? Okay, so these are some important points you need to know. So all atoms want a full outer shell of electrons. Yeah, they all want to get that noble gas configuration. To do this, they can gain or lose electrons from the outermost energy shell. They'll either fill up the energy shell with electrons, or they'll empty an energy shell so that they go to the next one down, which is full. So the number of electrons of negative charge will change. Okay, if you had 6, for example, if we had, let's have a look. So 2 and 6. So if we had 8 electrons before, and we needed 2 more to get a full outer shell. Originally we had 8 minuses, then we'd have 10 minuses, okay? And that will change. But the proton number is always the same. The proton number does not change. If you change the proton number of an element, you have changed what the element is. You fundamentally cannot do that. You can't change the proton number. Okay, we cannot change elements. So the proton number always stays the same. Right, but if we do lose or gain electrons, our balance between electrons and protons is no longer equal, and it will result in a charge, okay, either a negative or a positive charge. And quite often we can see the charge displayed next to the element in the formulae, for example, Li plus and Cl minus. If something's written down without a charge, without a plus or a minus, then it's neutral. Overall it is neutral, it has no charge. Okay, when things are written down with a plus or a minus, that is the indication that they are a charged particle. They are an ion. Right, another thing to be aware of, so this is going to link in with your chemical changes course, okay? So oil rig, so oxidation is loss of electrons. So if an atom loses electrons, we can say it's been oxidized. And reduction is gain of electrons. So if an atom gains electrons, we say it's been reduced. Now you can hear these terms used in terms of oxygen as well. So if an atom binds with oxygen, we sometimes say it's oxidized. And if an atom loses oxygen, we say that it's been reduced. Okay, but in this case, in this particular case where we're looking at ions, we're talking about the movement of electrons. So oxidation is loss of electrons, reduction is gain of electrons to form a charged particle. So an ion is a charged particle. It can be an element form or it can be a compound form, and we'll look at that in a little bit. So we're going to run through some examples of how ions are formed. This is where the amazing graphics are going to come in, guys. So I know it is exciting, but hold your breath. It's going to be a rocky road because it's the first time I've done this, so hopefully it will work. Right, so here we are. So we're using lithium as our example. As you can see, the proton number's there with 3. In order to have no overall charge, the number of electrons in a neutral atom is the same as the number of protons. So to start with, what we'll do with these examples is I'll talk you through the atom, I'll talk you through the change that it goes through, and then I'll show you how to draw the ion. Right, so here's our atom. Okay, little lithium by himself there. Could be a she, of course. Lithium, so it's 3 electrons, 2 on that first shell, 1 on the outer shell. And we can see in the table that we've got protons that are positive, electrons that are negative, and we're looking for an overall charge. So if we fill that table in now, we've got 3 protons, 3 electrons, and no overall charge. Atoms want a full outer shell of electrons. Remember, we can gain or lose. So we could fill that shell up, or we could just lose an electron to go down to the next energy shell. And atoms are lazy. Okay, they're going to do the one that requires the least amount of movement of electrons. Okay, so in this case, it's going to be much easier to lose 1 electron. And that's what happens. It loses 1 electron. So you can see now that next energy shell, that electron's gone. There's amazing graphics showing that electron, that has gone. And we're just left with the empty energy shell. And quite often what you'll do, you'll get rid of that energy shell now just to show the new outer shell. So lithium now has a new outer shell with just 2 electrons in. And now we need to count up our protons and electrons to see if we have a charge. So the protons, we cannot change the protons. Remember, you can't change protons. So the proton number is the same still, 3. Electrons has now changed. We've lost 1. We've gone from 3 to 2. So the overall charge now is +1. And so we need to draw our ion out as this. There we go. So we use these square brackets around our ion, and we put the little plus on the outside to show that it has a charge. Generally in chemistry, you don't put the number 1. Yeah, you don't put 1 in front of all of your chemical formulae to say you've got 1 mole. Okay, if there's nothing there, it basically means 1. So plus with nothing just means +1. And this is our ion. Okay, so our outer shell is there. We've got the square brackets and we've got the charge in the top right corner. Okay, so has this been oxidized or reduced? Remember, oxidation is loss of electrons. So has lithium lost electrons? Yes, it has. So the metal has been oxidized to form a positive ion, known as a cation. All right, so just to say as well, you only have to show the outer shell electrons. I mean, at the moment with lithium, we have the shell we've got is the outer shell, okay? But when we get to bigger atoms, okay, you'll have more shells inside that aren't involved. But when you draw your ion, you only have to draw the outer shell electrons. And hopefully I'll show you on the next couple how that is relevant. All right, so here we're looking at sodium. So we've changed to sodium. The proton number is 11. And so here is our electron arrangement for our sodium atom. There we go. So we've got our 3 shells, 2 on the first, 8 on the second, and 1 on the third. And this is a normal atom, so it's going to be neutral overall. There's going to be no overall charge because we've got 11 protons, 11 electrons, so 11 pluses, 11 minuses, 0 overall. So again, remember, atoms are lazy. They are going to gain or lose the fewest amount of electrons as possible because they're lazy. They don't want to be moving electrons. So the easiest thing to do here is for sodium to lose that outer electron, which it does. Okay, so that outer shell now is empty. So we end up with a new outer shell, which is effectively the second shell for our sodium. And we can put in the protons and electrons that we've got now. So we've got 3 protons. We've lost an electron. So we've gone from 11 to 10. So 11 positives and 10 minuses. We've now got an overall charge of +1. Okay, so we can draw the ion out. So as before, you only have to draw the outer shell electrons. Okay, so you can see here that the inner shell there of sodium that had 2 electrons on, I haven't bothered drawing that out for you. Okay, so we've just got the outer shell electrons and our charge in the top right corner outside the square brackets to show that it is a positive ion. Good, so has this been oxidized or reduced? Yep, you've got it now. You're getting the hang of this. The metal has been oxidized to form a positive ion known as a cation. Okay, so now we're going to look at magnesium. Okay, magnesium has a proton number of 12, so it's got 12 protons. So you should know straight away now, how many electrons does it have? 12, yeah, exactly. So we're going to draw out the atom now. There we go. So we've got our 12 electrons. Then we can fill the table. 12 protons, 12 electrons, neutral charge overall. There's no charge. Right, atoms are lazy. Are we going to gain or lose electrons? What's the easiest? Gain 6 or lose 2? Atoms are lazy. They're going to move the fewest amount possible, so they're going to lose 2 electrons. So there we go. Magnesium's outer shell is empty now, but it's happy because it's got a full shell. The next shell down, the new outer shell, is full. So we can count up our protons and electrons again. Protons haven't changed, okay? We have not changed the element. Our proton number is the same, so it's still 12. And the electrons, if you count those up, we've got 10, all right? So overall, 12 minus 10 leaves us with a charge of +2. Right, now then, drawing the ion out, again, we only have to show the outer shell. Right, so there we are, the outer shell. I've taken away the inner shell of magnesium. Once again, these are amazing graphics that I've used, and they have taken me a long, long time. Okay, so I really do hope you appreciate this. Right, so on the charge there, we've put 2+. Okay, so that is the conventional way to do it, 2+ for a charge of an ion. Okay, so even though in the table there I've put +2, okay, that was just basically because I'm working out a calculation and it's given me a positive answer. But in terms of the convention of writing the charge of the ion, we tend to put the number first and then the the actual sign of the charge afterwards, so it's Mg2+. Okay, so oxidation reduction. Have a guess. Well, don't have a guess. You should know by now. Remember the oil rig, oxidation is loss, reduction is gain. Yep, the metal has been oxidized to form our positive cation. Okay. Right, so we've been looking at metals. Right, let's have a look at non-metals then and see if that's any different. Okay, here we are, fluorine. Okay, most reactive element in the periodic table, right at the top right there. Fluorine in group 7, halogen. Okay, proton number is 9. So let's draw the atom for fluorine. There we go. So we've got 7 in our outer shell now. So 2 in the middle, 7 on the outside, 9 in total. And we've got 9 protons, so it's 0 charge overall. Remember, atoms are lazy. They're going to move the fewest amount possible. So is it easier to get rid of 7, move 7 things, or just move 1 to come on over? Yep, you've got it. It's going to gain 1 electron to get that full outer shell. So there we go. As you can see, we've shown that as a circle, just to show, well, a dot really, because these are called dot and cross diagrams. So it's a dot to show that that electron has come from somewhere else. Yeah, it identifies the electron that we've gained. If they're all crosses, we wouldn't know which electron we've gained. Okay, so it's important that you use dot and cross to show that it has gained an electron. And it's now got a full outer shell. So there's 8 in that outer shell and it's full. But now that we've done that, we've changed the number of electrons we've got. So we did have 9 protons, 9 electrons. But now we've got 9 protons, 10 electrons. And because you've got 9 pluses and 10 minuses, overall, you've got a charge now of -1. So if we write the ion out, as before, we don't have to show the inner shell, you only show the outer shell. So there we go, we've got our fluorine, well, it's a fluoride ion, I should say, a fluoride ion with its negative charge in the top right outside the brackets. And this time, have we been oxidized or reduced? What do you think? You got it, reduced to form a negative ion known as a anion. Okay, right, let's look at another one then. Slightly bigger atom this time, chlorine, 17 protons. So how many electrons has it got? 17, well done. Okay, let's draw out the atom. There we go, not much room. We're getting a bit cramped now, but hopefully you can still see that. So we've got our 17 protons, which means we've got 17 electrons, which means we've got 0 charge overall. Remember, they're lazy. They're not going to move 7 somewhere else. They're going to just move 1 to join them. Okay, so we're actually going to gain 1 electron. There we go. We've gained our electron to get that full outer shell. So now, when we look at things, we've got 17 protons still, because protons don't change. They're going to stay the same. Okay, but now we've got 18 electrons, so we've got a charge of -1. So when we draw our ion, we can get rid of those 2 inner shells. We don't have to draw those. Okay, they're only there because I'm showing you the whole thing just so that you can understand it a bit better. But when we draw the ion, we just draw the outer shell. We've drawn our dot to show that the electron has come from somewhere else, and we've got the charge outside the top right corner of our ion. And this time we've gained an electron, so we have been reduced to a negative ion, which is an anion. Okay, so coming up next, Okay, folks, right now we're going to look at oxygen. So oxygen has a proton number of 8. So how many electrons does it have? Yep, you got it, 8. Okay, so here's our atom of oxygen. So we've got 2 on the inner shell and 6 on the outer shell, giving us 8 electrons. The proton number is 8, electrons is 8, so overall we've got 0 charge. Okay, right, so again, atoms are lazy, okay, they don't want to do a lot of work. So is it easier to move 6 electrons to get a full outer shell or gain 2? Okay, the easiest thing we can do here is gain 2 electrons. Okay, so we're going to do that, and what I've done there, you can see how I've paired up the electrons with the oxygen electrons that were originally there, because that's that is how it would work. You would have a pair of electrons, okay? So they tend to go as pairs. So I've done it like that deliberately, okay? So what we've got there, we've now got a full outer shell. We've gained 2 electrons. So our protons is the same. We have not changed our protons, remember. We cannot change the protons. So protons is 8. Electrons we now have 10. So overall we've got a charge of -2. And so when we draw this out again, if you look in a moment, you're going to see that we don't bother with that the inner shell. We do have the outer shell, and you can see that overall we've got a 2- charge on the outside, the top right of our square brackets there. So that's the ion, okay? So has it been oxidized or reduced? Yep, you've got it now. Okay, this has been reduced to a negative anion. Okay, excellent. So that's how we draw our ions, and hopefully that's taking you through the process of knowing how we get from the atom to the ion and why it actually has a negative or a positive charge. Okay, so it's really, really important, and it will come in a lot when you do the chemical changes topic, ionic bonding. Okay, this really is a fundamental skill that you need to know. You need to be able to determine what ions different things are going to form. And there's a bit of help with that. You don't have to do it by memory. The periodic table can really help. So ions in the periodic table. So the periodic table, there are similarities and trends in the electron arrangement between elements in the same group. Okay, so that's going to help us with our ions. Generally, the way one element in a group behaves will be the same as the others. So the same number of electrons in their outermost energy shell. This is sometimes called the valence energy shell. So they have similar chemical behavior, and they will lose or gain the same number of electrons as the other elements in the group when they form their ions. So everything in group 1 will behave in the same way. Group 2, group 3, etc. If you know how one behaves, you'll know how the others behave. So there's a table here with the different groups, and you can see in a moment, I'll move it on now. So group 1 always forms a positive ion. Group 2, 2+. Group 3, 3+. Group 5, 3-. Group 6, 2-. And group 7, -. And you can see the examples there. I mean, we've seen lithium earlier in the video. Magnesium we saw as well. Aluminium, okay, it's a 3+ ion. It's exactly the same process as those other two. But instead of losing 1 or 2 electrons, this time it's lost 3 electrons. And that's the same. We saw fluorine and oxygen earlier, and nitrogen, same process. Instead of gaining 1 for fluorine, 2 for oxygen, with nitrogen you've gained 3 electrons. Okay. Okay, another note to be made aware of, transition metals. Okay, they are in many of the compounds you will come across, that big block in between groups 2 and 3 on the periodic table. They can form ions of different charges. So you've got, for example, iron, okay, iron, I-R-O-N, an iron can either be Fe2+ or Fe3+. So the formula for these compounds will usually contain Roman numerals that identify the charge of the metal ion. So you'll see things like iron 2 chloride and iron 3 chloride. So those Roman numerals, they tell you the actual charge of the ion. Okay, so if you're unsure, it should actually tell you. But there's other things like silver, Ag+, zinc, Zn2+. You really should be aware of those. Copper tends to be 2+, but it can be just a single positive. So you need to be aware of these things. Okay, and if you're one of my students at school, you probably will have been given an ions sheet with all the different sorts of ions on, and you need to learn those. Okay, there's with the transition metals, you need to learn them. Okay, but with the other group 1, 2, 3, 5, 6, 7, you can just work those out from the periodic table. Right, as I mentioned at the start, the very beginning, there are some polyatomic ions. Okay, so compounds can be ions too. So OH-, which you'll have come across doing acids and alkalis. Okay, and SO4 2- is another example, a sulfate ion. Particularly in the chemical changes topic, or when you're looking at making salts and electrolysis, these will come up a lot. Okay, so you need to know the charges of polyatomic ions, and it will help you to determine the formulae of the salts. So if you're anything like my students, when they see an equation, they find it very hard to actually come up with the chemical formulae themselves. Okay, so what we try and do is spend some time looking at the ions, and then you can actually work out how many of each different species you need in that compound in order to have a neutral charge overall. Because remember, a normal formula, if it doesn't have a charge on the outside displayed, then the charge overall should be neutral. So your positive ion and your negative ion should balance each other out. Okay, so the common polyatomic ions that you need to know are here below. You will come across these in your GCSE. A level there's a few more, but certainly for GCSE you should be aware of these ones. Okay, right, well that's brought our fantastic new graphics of the ions video to an end. Make sure your notifications are set, share this with your friends, get some more subscribers, and look out for the next Mr Hutton Science video coming very soon.